look like flips. All right. You don't mean like reflects across the x-axis, do you?
No.
Now, one way we can cheat is we can use Mr. Belotti's numbers. Mr. Belotti said that x and y, and this is -2, that's 4, -1 is 1, 0 is 0, 1 is 1, and 2 is 4. Didn't we just switch where the x and y are? Mr. Sussman? Didn't we switch where the x and y are? Right?
Yeah.
And so this is an inverse, is it not?
Yeah.
So therefore, the function, if I just make my xy table, just figure it out quickly, would be 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, would it not?
For the inverse?
Right.
Yeah.
So this would be x equals y squared for figuring out what it looks like. And I think you did figure out what it looked like. I just want to make sure that we're talking the same thing. Everyone else is with us. So we got 4, 1, 2, 3, 4, down 2. We have 1, -1. We have 0, 0, 1, 1, and 2, 4. And so this function comes in like this and goes back out like that. That's what you were saying, right? More or less? So it's
Yeah.
Okay. All right, and then, so when we switch x and y, all that happens is we end up with it on its side. There's one other thing that we need to be aware of. That's not a function, correct? How do I know it's not a function, Mr. Sussman?
It doesn't pass the vertical line test.
Beautiful. Like a math major right there. All of us are standing with awe. It's exactly the right phrasing and everything. All right, so let's flip this over, and then we're going to stare at 4 for a moment. And I'm going to make Miss Jordan do it, because she's facing out right now. Take a look at number 4 and start thinking of it. Just think about it for a moment before we start jetting into it. We've switched x's and y's, so everything is going to be switched for x's and y's. Things that go up are now going to go to the right. Things that will go down would instead go to the left. Yes, sir?
So I mean, it's like the y minus 3, but I mean, it's going to be usually a -3 would be going to the right.
So it's going to go to the up instead. Or it's going to go in the +3 y direction, right? Which is up. All right, Jordan, you ready for this? Yeah. Let's do this together. It's the first one. Getting this wrong is completely reasonable because I'm asking you to do something ridiculous. Uh-oh, my graph paper is bad. Well, we'll find out in a moment. That's okay. Okay, so here we go.
Okay, so the negative would flip across the y.
So yes, we're going to reflect across y instead.
And then the 2 would stretch it.
Well, which way did it stretch it? In the x direction, right? I see your fingers are pointing the x direction. So we're going to multiply, so it's stretch by 2x, right? So we're going to double our x values this time around. All right, what else you got? Up 3. Right 4. Beautifully done. Beautifully done. I don't think you've ever gotten through that without making a mistake somewhere. All right, let's do this. So reflect across the y-axis means that these points I've got are going to be here, here, here. 1, 2, 3, 4. Here and here. Next up, it says stretch by 2, but that's in the x direction. So multiply x values by 2. So this one here stays in place. This one here is going to go, this is -1 for x, this becomes -2 for x. Right? This is 4, so this becomes 5, 6, 7, 8. 5, 6, 7, 8. So far, so good?
Yes.
Okay, and then next up, it says up 3, so I'm going to move all those points up 3. 1, 2, 3. 1, 2, 3. 1, 2. Oh man, I'm right in the middle of all my work. Look at that. Could not have done this worse. 1, 2, 3. 1, 2, 3. Teacher, I'm prepared for class.
And then
Right 4. So right 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's a, you can't see that dot. 1, 2, 3, 4. Woo! Now we're doing crazy stuff for no good reason. But it's doable, isn't it? My rule is that you theoretically already know how to do. All right, with that in mind and us having so much fun, I'd like everybody to try number 5 without any help at all, although I know most of you are going to stumble. Try number 5. I want you to feel what it looks like when you've got the problem you're about to have. I'm going to need a volunteer or a victim to show us how to do number 5 in just a moment.
So y squared minus 4y, like made into a parenthesis thing.
Ooh, you are way ahead of the curve. I was waiting. I didn't think you saw that at all. Look, you were trying to get x by itself, right, aren't we?
Yeah.
And we want to get x by itself. The thought is, hey, all I have to do is just get this x by itself, and then I can solve the other side, make it look like what I want it to look like. Now, what do you mean by this parentheses thing? Do you have any words for that we should be using?
Or you can find the square then.
Complete the square, right? We could complete the square on that side. We could indeed. So we probably should do that, huh? All right, let's go ahead and do that. So as I get ready to do that, I'm going to do y minus, so half the middle term squared plus 4. When I do that, so I have to do that side, right? The whole point of that is it sets us up for this nice little y minus 2 squared thing, which is actually something I know how to graph. Unfortunately, I've got a mess over here I've got to undo. So how to undo that mess? Isolate for x. So that means I'm going to subtract 4 from both sides. Divided by -2. Ain't that fun? Whoop, I got y's on both sides somewhere. That's not good. All right, here we go. Gonna graph this thing. All right. So it's going to open to the right, right? Because it's an x equals y squared 1 initially. What does this thing tell us to do? Flip across the y? I'm going to write flip across y because you guys got this flip down. Good. What's 1/2 tell me to do? Compress by 1/2. I'm going to still say stretch. And I'm going to say 1/2 x. Compress is the right word, so don't lose that word. But I have two words that do the same thing, drive me crazy in math. If you're stretching by 1/2, you're actually compressing. So when they say compress, all of a sudden the textbook changed that to compress by 2. Okay, enough. Just multiply your x value by 1/2, call it a day. All right, what else you got?
Up to.
Up 2, because that's the one attached to the y, we're going to go up 2. Up 2.
And you go right.
We're going to go right 2. Okay, so I get my first set of dots out there, so I've got it out of my way. I got 1, 1, 1, 2, 4, 2, 4. Everybody understand how I got those dots? You understand how I got those dots? Okay. Now it says flip across the y-axis, so I'm going to flip that across the y-axis. Oh, that dot's in the wrong place. 1, 2, 3, 4. Stretched by 1/2. What's that going to look like, sir?
The y value, the x value is half of 1.
Half. So if it's 4, it becomes 2. It's 1, it becomes 1/2. 0, it becomes 0.
Oh.
Next.
And is it up to?
Up 2. What did I do? I did something wrong. Oh, this, I didn't put that up 2. This should be here, and then that one should be there, and then I've got right there. And then
And then you do right.
right 2. So here, 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 and here. What a mess. There we go. All right, it's your turn. Go ahead and try number 6. Try number 6.